Welcome back guys on this wonderful platform that is BYJU'S Exam Prep. And as you know, we were going for a wonderful topic that is degree of freedom. Okay. And guys, when we are talking about the degrees of freedom, you have seen yesterday we started about that, and we are today going to discuss about a lot because we have just seen degree of freedom of an independent link in 3D. Yes or no? So guys, please like and share the session so that other students can also join. So please tell me, am I properly audible and visible to all of you or not? Yes, Midun, good evening. So let us start the session now. So guys, we have already started discussion about degrees of freedom, but by chance yesterday we were unable to complete this topic. So today we are going to complete this topic along with a number of problems. Okay. Abhishek, good afternoon dear. Abhimanyu, yes, let us start. Great. So guys, now we are starting it. So my dear, this is some detail about me. You know, the subject going on is theory of machines. Simple mechanism is the topic. And now the time have come for the concept capsules. And for you guys, it is going to be started from tomorrow. Tuesday and Saturday are the time for mechanical student. And I already told you that what is going to be there in the capsules. There you would be having some wonderful conceptual topics. Okay. So let us move further guys. So the timing would be 9 a.m. It is going to be premiere from tomorrow. And guys, one more information is on 8th May at 12:30 p.m. You're going to have a session. It is a kind of seminar or webinar, you can say. How to ace GATE 23 in the first attempt would be taken by Dheeraj Sardana Sir. So you can register for free for such session. Okay. So let us start the session guys now. So my dear, as you know, we were having discussion about degrees of freedom. Yes, just a week. So guys, we were having the discussion about the degrees of freedom, and we have already seen the degree of freedom for a link in 3 dimension. Okay, I defined about that. And my dear, if we are going to discuss about some other pairs, so I will say degree of freedom of a link in pair. So when we are talking about the pairs, these type of questions are coming in GATE as well as in engineering services both. Sunil, good evening dear. How are you? How are your preparations are going on? So my dear, here I would be writing about which pair I am talking about. And my dear, then I would be writing here the degree of restraints or restricted motion. Then you know degree of freedom formula is 6 minus R. So my dear, yesterday we have discussed about the turning pair. And when we have discussed about the turning pair, you very well know that this is link 1, this is link 2. And when we are talking about the turning pair is between the two link like this. And you know, we cannot go for translation in X, we cannot go for translation in Y, we cannot go for translation in Z. We cannot rotate it about X, we cannot rotate it about Z, but we can rotate it about Y. So my dear, those motions which are possible without breaking the connection between the links, they would be called as the permitted motion, and the motions which are not possible without breaking the joint between them, they are said to be restricted motion. So my dear, only this one motion when they are going to rotate about the y-axis, this is the motion which is possible without breaking the joint. So only one motion is permitted. So restrictions are 3 translation plus 2 rotations. So these are the restricted motion. So my dear, degree of freedoms are nothing but 6 minus 5. It is going to be 1. So you can remember it that for a turning pair, degree of freedom is going to be 1. Is it clear for everyone? So guys, just like and share the session so that we can have more and more peoples to join. And my dear, now we are going for the second case. The second case, my dear, first you have seen the turning pair. Now, my dear, we would be having an arrangement where we would be having a cylinder. This is a cylinder, and my dear, in this cylinder we have a piston. In this cylinder we have a piston, and you know, when you have this piston inside the cylinder and the similar kind of connection you have seen at your home when you are having the door closer, that is also known as kundi. So there you have a cylindrical arrangement like this. On this is a stand handle actually, and you can have you are actually having there some closer like this, and when you are moving it, you are closing the door like this. So my dear, this can be rotated like this and this can also reciprocate like this. In other words, piston in the cylinder can reciprocate like this. It can also rotate like this. So my dear, you can see one translation and one rotation is permitted. So you can see if you are going to take this piston translating in X direction, it is possible. If you want this piston translating in Y, not possible because it has to cross the cylinder in that case. It cannot come outside the cylinder like this. So two translations are restricted here. Similarly, my dear, when we are talking about this, if you are talking about rotation, my dear, if you have this piston inside the cylinder, then my dear, this piston can only rotate about X axis. This piston can only rotate about X axis. It cannot rotate about Y. If you will try to rotate the piston about Y axis, it is not possible. Inside the cylinder, it cannot be possible because inside the cylinder, it is like this. So it can only rotate like this. No other kind of rotation is possible. Otherwise, it has to cross the cylinder, my dear. So you will say plus two rotations are restricted. So we can have only one translation, one rotation. So 6 minus 4, degree of freedom is coming out to be 2. My dear, if we have the third case as, the spherical pair you have seen. When we are talking about the spherical pair, in case of spherical pair, when we are talking about, let us say you have the spherical pair like this. My dear, in this, if you see the connection between your hand and the arm, if you see, so my dear, if you will try to take this in the X direction and try to translate in X direction, my dear, this translation will not be possible. If you will try to translate it in Y direction, it is not going to be possible. Translating in Z direction will not be possible because it would be, again, if you are going to try this, my dear, आपका हाथ आपके हाथ में आ जाएगा. So it is going to be a loss, obviously. So my dear, this kind of motion is not possible. You can rotate about X axis, rotate about Y axis, you can rotate about Z axis. So these three rotations are possible. So my dear, if these three rotations are possible, I will say three translations are restricted. So 6 minus 3, we would be having 3 degree of freedom. So there are some cases of degree of freedom 1, some cases of degree of freedom 2, some cases of degree of freedom 3. So we can have 1 to 6 all the cases. Now I am going to show you other 3 cases, guys, and then we would be entering into the Kutzbach equation and all. Because from this table many times question have been there in the GATE examination. So we are doing all this exercise. So my dear, let us see the 4th case. If we are going to have a table, and on this table, if we have a cylinder like this, if we have a cylinder on a table, my dear, you know that this cylinder, if it is placed on a table, so I am having a table for you, this is a cylinder. So this cylinder can rotate about x-axis, yes, there is no issue. If it is going to be rotated about x-axis, there is no problem. If it is going to be rotated about y-axis, there is no problem. Connection between table and cylinder is not going to be broken. But rotation about z-axis will definitely cause that the motion, the connection between them would be broken. Because we have considered this as x-axis, this as y-axis, and this as z-axis. So these are the axes of consideration. So when you are going to have cylinder on table, then my dear, you can see the translation in x direction possible, translation in y is not possible, translation in z is possible. So translation in x possible, translation in y not possible, translation in z is possible. So I will say one translation is not possible. Is it clear? If you are going to have rotation, you can just see rotation about x is there, rotation about y is there, but rotation about z is not there. So you can see one rotation is also restricted. So out of total 6 minus 2, 4 are the permitted motions. This is the case of cylinder on a table. So my dear, now we are going to have a sphere on a table. Let us say a Costco ball or a football is present on the table. My dear, if a football is present on a table, that football can travel in x direction and y direction? No. It can travel in x direction, travel in z direction, but cannot travel in y direction. So my dear, one translation is restricted here. But my dear, this football can rotate about x-axis, can rotate about y-axis, can rotate about z-axis. No one is going to stop this. So my dear, I would be saying that one translation is restricted, and my dear, 6 minus 1 degree of freedom would be coming out to be 5 here. So 5 degrees of freedom would be there for this case. And when we are going to have an independent link, then there is no restriction, degree of freedom would be 6. Is it clear for everyone, guys? Yes. So this is the case of degrees of freedom. Now let us move further. So my dear, this we have seen for a link in a pair. Now let us talk about a mechanism. Now we will see degree of freedom for a 3D space mechanism. So when we are talking about 3D space mechanism, my dear, first of all, we have written 3D. Let us say in 3 dimension we have L as the number of links. This time we want to write the degree of freedom of a mechanism. My dear, if L is the number of link, you know that for one link we have maximum of 6 degree of freedom. So my dear, if we have L number of links, so for L number of links, total degree of freedom in 3D are going to be 6 into L. But you have already mentioned it is a mechanism. We are going to make a mechanism whenever some of the link is going to be kept fixed. So for a kinematic chain, if one link is going to be kept fixed, it becomes a mechanism. So my dear, according to that, we need to write here 6 into L minus 1. Now my dear, when you will be finding out in a mechanism, there would be a number of pairs present. And let us say you find some P1 number of pairs. Which are having degree of freedom to be equals to 1. So for these are the example of turning pair. So let us say there are P1 number of turning pair present. For them, degree of freedom would be 1 and degree of restraints would be 5. So degree of freedom is 1, degree of restrictions are 5. So my dear, if one pair is having 5 restriction, P1 pair would be having 5 P1 restrictions. Just from the unitary method, we would be reducing this number as minus 5 P1. Similarly, my dear, if we are going to have P2 as the number of pairs with a degree of freedom equals to 2, you would be having restrictions to be equals to 4. So for one pair there are 4 restrictions, for P2 pair there are 4 P2 restrictions, we will say minus 4 P2. Similarly, my dear, we would be having minus 3 P3, we would be having minus 2 P4, minus P5. So this is the formula for degree of freedom of a mechanism in 3D. So 3D space mechanism. Guys, please tell me, is it clear to everyone or not? But you know, in our syllabus we are restricted to 2D cases. 3-dimensional things are not in our syllabus much. So we would be moving towards 2D now. Okay, so let's enter into 2D. So for 2D, what is going to happen? For that we will see degree of freedom in 2D. Yesterday I have shown you the animations also. Today we have a number of questions to solve, guys. Let us start now. So when we are talking about 2 dimension, it means Z dimension is not there now. We have only 2 dimension, X and Y. So body would also be a 2-dimensional body now. So my dear, when we are talking about the motion of this body can translate in X, this body can translate in Y. So my dear, translation in X is one motion, translation in Y is another motion. If you are going to translate in Z, Z dimension is not there, so translation of Z is not there, so only 2 translation motions are there. When we are talking about rotation, if you will try to rotate it about x-axis, my dear, when you will try to rotate it about x-axis, the motion is coming in the plane which would be consisting of z-axis. So z-axis is not there in 2D, so any such motion which is coming in a plane consisting z will not be allowed. So you can just rotate this in this xy plane only. So if this would be rotating about in xy plane, this is nothing but the rotation about z. So XY plane rotation is rotation about Z, but Z axis is not involved in that rotation. So you will say rotation about Z. So these are the three permitted motion. These are the three permitted motion, the maximum possible motion in 2D. So my dear, if somebody asks you the maximum degree of freedom of a link in 2D, it is nothing but 3. The maximum motion which are possible in 2 dimension are nothing but the 3. And if you are going to make any pair, so you know pairing imposes restrictions. Pairing imposes restrictions. So my dear, when you are going to impose any kind of restriction, the degree of freedom would become 3 minus r. Like previously we had 6 minus r, this time we have 3 minus r. So my dear, if you are going to write the formula for degree of freedom in 2 dimension, my dear, you would be going to follow the same procedure like you have degree of freedom for a 2D planar mechanism. So you would be defining it, degree of freedom for 2D planar mechanism. So we will write it as degree of freedom for 2D planar mechanism. 2D planar mechanism. So my dear, when we are going to write this degree of freedom for 2D planar mechanism, I would like to tell you one thing that, f of 2D, let us say we have L as the number of links. L as the number of links. So my dear, if L are the number of links, one link can have maximum of 3 degree of freedom. So L number of links can have maximum of 3L degree of freedom. So it is going to be 3 into L. But as you are calling it as mechanism, one link must be fixed. So if one link must be fixed, it will become L minus 1. My dear, now let us say P1 are the number of pairs with degree of freedom is equals to 1. This time if degree of freedom is going to be 1, degree of restraints or restrictions would be 2. So my dear, if 2 restrictions are there, 1 degree of freedom is there for one turning pair, for one pair. So for P1 it is going to be 2 times of P1 and you would be writing minus 2 times of P1. Similarly, we can have P2 as the number of pairs with degree of freedom equals to 2. For that restriction is going to be 1 and you would be having minus P2. So this is going to be the degree of freedom for a 2D planar mechanism. 2D planar का maximum degree of freedom 3 होगा. बिल्कुल सही रंजीत, you are very much correct. So this is how you can write the degree of freedom for a 2D planar mechanism. So this was given, my dear, but later on it was converted into some other format by Sir Kutzbach. To understand that format, we need to understand the relation between higher pairs and lower pairs. We need to understand the relation between higher pairs and lower pairs. So when we are going to understand the relation between higher pairs and lower pairs, so my dear, for that I am going to make 2 similar mechanisms where we are getting same input to output motion. The very first case we are going to make is cams and follower. This is a cam we have. This is a follower we have. So my dear, when we have this cam and follower type of motion, you very well know this is link number 1, this is link number 2, this is link number 3, this is link number 1. All fixed link are link number 1 because they cannot have relative motion with respect to each other. Actually, Ranjit, I would like to tell you, you have written the right thing. But I would like to tell you, dear, actually for BYJU'S Exam Prep, there are 2 channels. One channel is for English audience, second channel is for Hindi audience. So this channel is dedicated to English audience, so I need to teach in English only. तो ऐसा नहीं है कि मैं अपनी मर्जी से सिर्फ इंग्लिश में एक्सप्लेन कर रहा हूँ, हिंदी नहीं आती मुझे, ऐसा नहीं है. I know both the languages, but this channel is dedicated for the English. Okay, so there are 2 channels. This channel we are bound to teach in English only, so that the audience which feels problem in Hindi वो समझ सके इसलिए, ओके, ऐसा कुछ नहीं है। चलिए, सो इफ यू सी गाइस, देयर आर नंबर ऑफ लिंक्स, देयर आर 3 नंबर ऑफ लिंक्स। माय डियर, इफ यू सी दिस इज अ टर्निंग पेयर. If you see this, this is a point contact, means it is a higher pair. This is a sliding pair, okay? And you know that if we are going to write there, one turning pair, one sliding pair. Turning pair is lower pair, sliding pair is lower pair. So there are 2 lower pairs plus 1 higher pair. This, whatever I am writing, is said to be the configuration of a mechanism. This is said to be the configuration of a mechanism. Now, my dear, we are going to have a similar mechanism which would be giving you the similar motion. That is a single slider crank mechanism, where we have a slider like this, a connecting rod like this, and we are going to have a crank like this. So, my dear, if you are going to have this, this is link number 1, this is link number 2, link number 3, link number 4, and link number 1. So if you see here, there are number of links as equals to 4. And my dear, this is a kind of turning pair once again, a turning pair once again, a turning pair once again, and a sliding pair. This time turning pair, turning pair, turning pair, and sliding pair. And my dear, by chance, all these pairs are lower pairs. So we would be writing the number of lower pairs are equals to 1, 2, 3, and 4, and there is no higher pair this time. If you compare these two mechanisms, my dear, cam is rotating, follower is reciprocating. Crank is rotating, slider is reciprocating. In both the cases, we have rotation to reciprocation. Rotation to reciprocation. It means both mechanisms are producing the same relative motion. My dear, if two mechanisms which are producing the same relative motion, for us, they are more or less same only. So if two mechanisms are producing same relative motion, we do not consider them different, but we consider them same only. Why? Because in theory of machines, our target is to produce relative motion. Same means they are equivalent for us. Same doesn't mean they are equal, they are equivalent. एक जैसा relative motion they are providing. So my dear, if they are providing similar relative motion, so my dear, we can compare them and we can say they are equivalent for us. So if you will see here, there are 2 lower pairs plus 1 higher pair is doing the same work, which on the other side is done by 4 lower pairs. So 4 lower pairs can be written as, this is 2 lower pair plus 1 higher pair. You can write it equivalent to 2 lower pair plus 2 lower pair. So my dear, 1 higher pair is equivalent to 2 lower pair. So the point is, the work done by a single higher pair is equivalent to the work done by the 2 lower pairs. So this is the conclusion of this. Is it clear, guys, for everyone? So we concluded 1 higher pair is equivalent to 2 lower pairs. Now we are going to use it, okay? Now we are going to use it, and now we would be defining the Kutzbach equation. So we have seen this equation for degrees of freedom. We will also apply this equation to find out how to calculate the degree of freedom for different mechanisms. This is a class where we are going to do a lot of practice now. After 5 minutes, practice will start. It will go till next 25-30 minutes. So let us start, guys, without having any kind of delay. So my dear, when we are going to have this, we would be already knowing that we are going for Kutzbach equation now. So when we are talking about Kutzbach equation, so my dear, we have already written 3L minus 1 minus 2P1 minus P2. Kutzbach, a researcher, he have done a research and he have considered lakhs of mechanism. When lakhs of mechanism were considered, and he tried to convert into some different format, what he have done, you know, P1 are the number of pairs for which degree of freedom is 1. So my dear, if you are talking about turning pair is also having degree of freedom as 1. So if you see this turning pair, this can also be considered as a binary joint. So my dear, Sir Kutzbach have converted this number of pairs with degree of freedom 1 with the binary joints. So he converted P1 by J. And then you know that P2 is the number of pairs with degree of freedom 2. You know this is a turning pair. Turning pair is a kind of lower pair. So my dear, this lower pair is having a degree of freedom of 1. You know one higher pair is equivalent to two lower pairs. So one higher pair is equivalent to two lower pair. If one lower pair is having degree of freedom of 1, then two lower pairs would be having a degree of freedom of 2. And one higher pair is equivalent to two lower pairs, so it would be having a degree of freedom of 2. So my dear, that's why the pairs with degree of freedom 2 were replaced by the number of higher pairs. They were replaced by the number of higher pairs. We have done this to convert it into some equivalent format, some easy format. P2 was replaced by H. And now my dear, the new equation we had from the Kutzbach side, this was the result of a hard work of 5 to 6 years of Sir Kutzbach. And this was degree of freedom for 2D 3 into L minus 1 minus 2J minus H. This was the wonderful equation given the name of Kutzbach. So this equation is going to be used, and this equation was found to be useful for 99% cases. For 1% cases, this equation was not suitable for, but for 99% of the cases, this equation have given the right results and it is acceptable by them. So if you want to see those 99% cases example, we will see some of them and I am showing you some of them. So my dear, first of all, let us move. This was the equation. So 3 into, you can write N or L. So F is equals to 3 into L minus 1 minus 2J minus H. So this is the equation we had as Kutzbach's equation. So my dear, if you see this, we are going to calculate now the degree of freedom. Now we are starting with the problems. So if you have this as link number 1, this as link number 2, this as link number 3. So we can write here the number of links are 3. If you see, this is a binary joint, this is a binary joint, this is a binary joint. So my dear, we have, there are 3 binary joint. Degree of freedom formula, higher pairs are 0. It is 3 into L minus 1 minus 2J minus H. So 3 into number of links are 3 minus 1 minus 2 into 3 minus 0. So you would be having 2 into 3, 6 minus 6. Degree of freedom is 0. So my dear, when we are going to have degrees of freedom to be equals to 0, such kind of given linkages are said to be frame or structure. Because degree of freedom 0 means what? Degree of freedom 0 means there is no motion. There is no motion, because degree of freedom is defined as the number of variables required to define the motion of the system. If we are getting degree of freedom 0, it means there is no motion, because no variable is required to define that motion. It means motion is not there. So we would be calling there is no motion, and if motion is not there, we will call it frame or structure. So we will call it frame or structure. Is it clear for everyone, guys? Yes. Chaliye, let us move to the next, guys. Let us move to the next problem. So my dear, but when we have seen frame or structure, we were not feeling bad, because this may not be useful for us because we want motion. But this is useful for civil engineering application. This is useful for civil engineering application, because this is used in trusses, frames and all. So second question, my dear. Now we have second question. And before going into that, I would be giving one question from my side. Let us say we have a 4-link mechanism, or I will say 4 link are there. Link number 1, link number 2, link number 3 and link number 4. This is O, A, B, C. Let us say we have this, guys. Let us say we have this. So my dear, if we have this here, if somebody asks you the number of links, they are 4. If somebody asks you the number of joints, my dear, so this is one binary joint, this is another binary joint, another binary and another binary. So number of binary joints are 4. So if we have 4 links, 4 joints, there is no higher pair. You are going to have F3 into L minus 1 minus 2J minus H. You would be using this equation. F is links are 4 minus 2 into 4 minus 0. The answer would be 1. So when we are going to have degree of freedom to be equals to 1, it means one variable is required to define the state of motion. And my dear, it means there is a unique motion. And for unique motion, we are defining such things as kinematic chain. So my dear, kinematic chain whose one link is kept fixed is nothing but simple 4-bar mechanism. Simple because it is the very first type of mechanism of the universe. So it was given the name of simple 4-bar mechanism. So this is the first mechanism of the universe, my dear. It is given the name of simple 4-bar mechanism. Is it clear for everyone? Shall we move on now? Yes. So my dear, now we will calculate degree of freedom for this question number 3 for you guys. You know this is fixed link number 1, link number 2, link number 3, link number 4, link number 5. If you see once again, this is link number 1. So number of links are 5 here. My dear, I am calculating a number of questions in front of you so that you can understand how to use the degree of freedom equation. This is binary joint, binary joint, binary joint, binary joint and binary joint. So 1, 2, 3, 4, 5. There are 5 binary joints. There is no higher pairs, guys. So you will write degree of freedom equation as 3 into 5 minus 1 minus 2 into 5. If you see, it is 12 minus 10 coming out to be 2. So when degree of freedom is coming out to be 2, what do you mean by that? It means 2 variables are required to define the state of motion. It means we need to control 2 input to get a desired output. So my dear, whenever degree of freedom is coming out to be equals to 2, it means 2 inputs needs to be controlled. And when 2 inputs needs to be controlled, when जब दो input control करोगे, so my dear, you can get multiple types of output from the same given linkage. And my dear, such wonderful linkages were given the name of unconstrained chain. So they are unconstrained chain. Okay, this seems to be bad because I told you unconstrained motion are of no use for us. But my dear, when we are talking about this unconstrained chain, it seems to be of no use from the starting. But now when you know the degree of freedom concept, that 2 inputs can be controlled. So my dear, after getting the concept of degree of freedom, when we try to apply this on the unconstrained chain, we got to know that they are the best types of chain available. So my dear, the example for such kind of chains is epicyclic gear train. Epicyclic gear train, my dear, is an unconstrained chain, and my dear, that is much better than the kinematic chains like simple gear train, compound gear train. Why? Because in epicyclic gear train we are going to control 2 inputs and we are getting a number of possible outputs. So based on our requirement, we can change the type of output. So with one machine we are getting the outputs of many machines, which is an advantage. So my dear, when we are talking about normal gears, set of gears or gear train, they can give you only one speed ratio. Epicyclic can give you multiple speed ratio. So when one machine is working like many, then my dear, it is going to be a plus thing. So suppose you have one machine, on that you can do turning operation, drilling operation, shaper operation, all the operations, more than 4-5 operations. So that machine is useful, much useful for us. So my dear, that's why I said these are nowadays kings of chain, or I will say queen of chain. So unconstrained are not bad thing. They are more useful nowadays by using the degree of freedom concept. Very good, Abhimanyu. So my dear, now let us see the degree of freedom for, okay, before we enter into that, let us calculate for some good cases. This case, we need to find out degree of freedom of this case. If you see, this is link number 1, link number 2, link number 3, link number 4, link number 1, link number 5, link number 6, link number 7, link number 1, link number 8, link number 1. If you want to try along with me, you can also try and give me the answer for that. So this is a question you need to find out the degrees of freedom now. So when you will try to calculate the degree of freedom, we had the number of links to be 8. So we have number of links to be 8. And my dear, if we try to find out the joints, this is a binary joint. This is a binary joint. My dear, now the confusion starts when we entered into this point. If you see this point, at this point we have link number 3, we have link number 5, we have link number 1, we have link number 5. So there are 4 links. So it is a quaternary joint. Once again, binary, 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 binary and binary. So if you identify this quaternary, there is no mistake. You know, in our formula, J is the number of binary joint. So we need to convert quaternary joint into binary one. So this is 1 binary, 2 binary, 3 binary, 4 binary, 5 binary, 6 binary, 7 binary. Once again, 1 binary, 2 binary, 3 binary, 4 binary, 5 binary, 6 binary, 7 binary. And this is 1 quaternary means 3 binary. This is 3 binary. So 7 plus 3 is 10 binary. J is 10. So you know formula is 3 into 8 minus 1 minus 2 into 10. There is no higher pair. You will be writing 7, 3, 21 minus 20. Answer is going to be 1. Very good, Midun. Wonderful, dear. बहुत ही बढ़िया. Okay. So guys, just like and share the session. This is a practice session. More student means more practice. So let us say this is link number 1, link number 2, link number 3, link number 4, link number 5, link number 6, link number 7. So if you see the number of links, they are 7. This time, my dear, there is a issue, that is a higher pair is also present. So higher pair is also present. Let us see the joints. Binary, 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 binary and binary. So first binary, second binary, third binary, fourth binary, fifth binary, sixth binary, seventh binary, eighth binary. We have 8 binary joint. So degree of freedom would be 3 times 7 minus 1 minus 2 into 8 minus 1. 6 3 ja 18 minus 16 minus 1. Answer is 1. Is it clear, guys? This is how we can find out the degrees of freedom. Are you getting it? Very good, Midun. Very good, Abhimanyu. Wonderful, dear. Let us move further to the next question. We have solved question number 5 also. Let us see the next question. Okay. For this, I am skipping some question because they would be using modified Kutzbach. Link number 1. So my dear, this is link number 1, this is link number 2, this is link number 3, link number 4, link number 5. Because this complete link is a hatched link. So we would be considering this complete link as single link only. This is also hatched link. So that would also be considered as a single link. So if you see, this is 1, 2, 3, 4, 5. The number of links are 5. Higher pairs are 0. Binary joints. This is a binary, this is a binary. This is a binary, this is a binary. This is a binary, this is a binary. 6 joints. Try this, get the answer. Try this, get the answer. Degree of freedom. 3 into L minus 1 minus 2J minus H. 3 into 5 minus 1. Yes. 12. 0. Very good, Midun. Very good, Abhimanyu. A is going to be the answer for this. Wonderful, guys. Wonderful. Let's move further. Okay. नेक्स्ट इज दिस वन. सो एक लाइन से हम कुट्ज़बैक वाले कर रहे हैं, उसके बाद हम मॉडिफाइड कुट्ज़बैक भी सीखेंगे. लिंक नंबर 1, लिंक नंबर 2, लिंक नंबर 3, लिंक नंबर 4, लिंक नंबर 5, लिंक नंबर 6, लिंक नंबर 7, 8 and 9. So hatched link is considered to be a single link only. It is like if you can have these 4 pens joined like this, then these 4 pens are 4 different links. In place of these 4 pens, if I apply one this body, it also have 4 sides, but they are like a single link only. So hatched means single link. If you see, the number of links are 8. Number of joints, 1 binary. This is a ternary joint. 3 links are connected here. This is also a ternary joint. 3 links are connected. This is also a ternary joint. 1, 2 and 3. This is also a binary joint. 1 and 2. This is also a binary joint. 1 and 2. This is also a binary joint. 1 and 2. And this is also a ternary joint. So number of joints, 1 binary, 1 ternary means 2 binary. So 1 ternary, 2 ternary, 1 ternary, 2 ternary, 3 ternary and 4 ternary. There are 4 ternary, you can check it. 1 ternary, 2 ternary, 3 ternary, 4 ternary. So 4 into 2. 1 binary, then 2 binary, 3 binary and 4 binary. 12. There is no higher pair. Yes guys, there is no higher pair. Degree of freedom. 3 into 8 minus 1 minus 2 into 12 minus 0. So 7 3 is 21. Are we doing this correct? Is there any mistake? The number of links, okay, number of links are 9, sorry. So it is 24. 0 is the answer. Yes, very good guys. 0 is the right answer. 0 is the right answer for this. Very good. So guys, now let us talk about the modified Kutzbach equation. Modified Kutzbach equation. For that we will see some case for modified Kutzbach. We have many examples today. This is the case to understand the modified Kutzbach equation. My dear, if you see this case and if you take it normally, this is link number 1, link number 2, link number 3, link number 4 and link number 1. If you see, number of links are coming out to be 4. Number of joints, this is a turning pair, binary joint, sliding pair. Actually, what is this? This is a hole. Actually, this is a rectangular hole. And in this rectangular hole, we are putting this link. So this link can slide from this. This is put it like on rectangular hole like this. So it can slide like this. So this link can slide. So this is placed in a rectangular hole like this. This is also once again a rectangular hole. On this hole, this is kept like this. So my dear, if you see the number of joints, it is sliding pair, it is sliding pair, it is turning pair. So sliding pair is also said to be binary joint only. So we get number of joints are 4. There is no higher pair. So if you will be trying to calculate degree of freedom, you would be getting 3 into L minus 1 minus 2 into J minus higher pair. You would be getting 9 minus 8. The answer should be 1. So it means for one input we would be getting one output. This seems to be the answer from the equation. But if you think slightly practically, if you will be giving rotation to this, my dear, as this link is kept on 2 rectangular holes like this, don't you feel this link will move in this direction and go away? And once this link would be going away, we would be left with 3 links only. And with 3 links, we shall have degree of freedom to be 0. Because for making a mechanism, the minimum number of links required are 4. You have seen 3 links can give you frame or structure only. So my dear, if that is the case, why we are getting answer as 1? That was the first drawback, or you can say ये पहला थप्पड़ एक तरह से इस equation को लगा. In this equation is not giving you the right answer. Then Kutzbach thought to revise the equation because he found that there is something missing. First of all, he thought it may be an exception, but then other cases also came with the same issue. Like one of the other case which came into picture was cam and follower with the roller follower case. If you have cam and follower with the roller follower case, my dear, if you have cam and follower with the roller follower case, when you would be giving rotation to the cam, this is link number 1, this is link number 2, this is link number 3, this is link number 4, and this is link number 1. So here number of links are 4 in number. And when you try to find out the number of joints, this is a binary joint. This is once again a binary joint. This is a binary joint because it is sliding pair. And this is higher pair. So there are 1, 2 and 3 binary joint, and higher pair is equals to 1. If you will calculate degree of freedom, it would be coming out to be 3 into L minus 1 minus 2J minus higher pair. You would be getting 9 minus 6 minus 1. The answer would be 2 for this. So my dear, you would be getting the answer as 2, which should not be the case because it is a cam and follower mechanism. It is a cam and follower mechanism which is having a degree of freedom of 1. So this was the second exception came to the Kutzbach equation. When this type of exceptions were coming in the path of Sir Kutzbach, then Sir Kutzbach got to know that I need to modify the equation. So my dear, then he started thinking what is missing here. And then what he found is there is an extra motion present in the mechanism because of which the answer is coming out to be 1. But that extra motion has nothing to do with input and output. Like as this link was present like this, even if you do not give input, you just push it. You just push it. If you would be pushing it, this link would be going down without giving motion to input links. So this motion is possible without input, without giving input. So this is an extra motion. That motion which is possible without giving input is said to be an extra kind of motion, and such motions are said to be the redundant motions. And Sir Kutzbach thought that if that motion is there, because of which degree of freedom is coming out to be 1. So he said that 1 should be 0 because this motion is giving the answer as 1. But that is not the part of mechanism. Because without giving input, this motion is possible. So he have given the name to such motions as redundant motions. And he said my new equation would be F is equals to 3 into L minus 1 minus 2J minus H minus FR. So he said FR is the number of redundant motions, those motions which are possible without giving any input. So when you would be reducing this 3 into 4 minus 1 minus 2 into 4 minus no higher pair, 1 redundant motion, answer would be 0. Similarly, in the next case, in case of cam and follower, this roller can be rotated without rotation of cam. So this is the redundant motion. So once again you need to put FR minus 1, answer would be 1. Yes or no? So my dear, this wonderful equation was given the name of modified Kutzbach equation. Abhimanyu, Midun, got it or not? Please tell me that. This is the modified Kutzbach equation. Yes or no? Yes or no? Fine. So we are moving further, guys. These were the questions. We are now going to solve this question, and this question have been asked in ISRO and IES examination. So this is a very good question. Here this is a turning pair. I would be reframing this question in this way. This is a turning pair like this. There is a slider. The same question I am making on figure. You need to find out the degree of freedom for this. This is a nice question, my dear, and you need to understand how to do such type of problem. Like here there are 1, 2, 3 closed loop. I have made 2. We can have one more loop also. The answer would be same only. So I have made less to make you understand. Many people are getting confused. First of all, they feel here, they feel this is one link, this is second link, this is third link, this is fourth link. So they feel it is 1, 2, 3, 4. First of all, here they are mistaken. Actually, the connection between the link is like the scissor we have. In scissor we have this connection. Kenchi, in scissor we have this connection, if you remember. Okay, so this type of connection, they are two link only. In plucker we have the same thing. In plas we have the same thing. So my dear, they are two links only. So they are two links joined with the turning pair here. So you will call this as link number 1, this is link number 1, slider is link number 2. So this is 3, this is also 3. This is 4, this is also 4. This is 5, this is also 5, this is 6, this is also 6. 7, 8. So if you see, we got the number of links as 8 here. Number of links as 8. This joint is binary, 7 and 8. This is binary, 3 binary, 4 binary, 5 binary, 6 binary, 7 binary, 8 binary. This is ternary. Because link number 3, link number 1, link number 2. Ternary means 2 binary. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Joints are 10. There is no higher pair, no redundant motion. Degree of freedom would be 3 into 8 minus 1 minus 2 into 10 minus 0. 21 minus 20. The answer would be 1. So answer is mechanism with 1 degree of freedom. Everybody clear or not? Please tell me that, guys. This is a wonderful question, have been asked in many examination. Is it clear for everyone? Yes? Tell me that. One more question, guys, in front of you. One more question in front of you. So whatever the question I have left, you would be getting this PDF in the Telegram channel, Mechanical by Dheeraj Sardana. So you can do practice those questions, okay? And I would be doing the remaining questions in upcoming classes one by one. Very good, very good. So if you see this, this is link number 1, link number 2, link number 3, link number 4. This is not hashed, na? 7, 8, 9, 1. If you see the joint, this is ternary joint, ternary joint, ternary joint, binary joint, binary joint, and binary joint. So my dear, if you see, these are 3 ternary. 3 ternary means 3 into 2, 6 binary. So if you see, the number of links are 9. Joints, 1 binary. 1 ternary means 2 binary. So 1 ternary, 2 ternary, 3 ternary. So we will write 3 into 2 first. 1 binary, 2 binary, 3 binary, 4 binary, 5 binary. 11. Degree of freedom is 3 into 9 minus 1 minus 2 into 11. There is no higher pair, no redundant motion. Answer would be 2. Very good, guys. So with this we are completing the session. We are closing here. So now we would be meeting tomorrow once again at the same time, and tomorrow the topic would be Gradeup law. We are going to learn one of the most important topic from where a number of questions are there. Tomorrow we would be completing that topic in tomorrow's class only. So let's join tomorrow for Gradeup law. So goodbye, guys, for this session. Thanks for joining.